Hello, it's Juho Webselainen from Finland, as you might tell by the background. And welcome to the opening session of React Finland 2021. And for obvious reasons, we're doing this all more or less online. So we have speakers from all over the world. We have 15 sessions, close to 50 speakers. And I guess I wanted to mention that we also have this online venue. Maybe some are watching it over there. And then we have this matchmaking at Prella. You can find a lot of this information at our website, react-finland.fi. But instead of boring you with these details, let's get on with the session. So maybe we do a brief round of introductions. So maybe Ryan, maybe you can tell a couple of words about yourself.
Yeah, sure. My name's Ryan. I am a JavaScript framework author. I work on the library SolidJS, and I also work on Marco at eBay, which is their multi-page app framework. I'm a long-time user of React, and definitely excited to be here.
Yeah, thanks. Cool.
Hey, my name is David Khourshid. Really excited to be here again at React Finland. I am the author of a state management / orchestration library called XState, and I also work at Stately, which is a brand new startup that I started. And yeah, that's about it.
Cool. And maybe Travis next.
Hey everyone, my name is Travis. I'm a designer and developer. I've been doing traditional graphic design for a while and then got into engineering. I work on React a lot. I love it. Contribute to open source as much as I can, and excited to be here today. Talk to you all.
Cool. And then last, Paul.
Hey everyone, my name is Paul. I'm an open source developer located in Switzerland, and I'm the author of a couple of React libraries, Zustand, React Spring, and React Fiber.
Cool. So thanks for the introduction. So before moving to the first talk, what are the feelings on the direction of React? I think React 18 is getting close. So what do you expect?
I don't know about you all, but I'm super excited. This stuff's been a long time coming. You can tell all the pieces are just starting to layer together in such a way that this is, in some ways, this is like a new start. This is the future. I'm really stoked on React 18.
Yeah, I'm personally excited that they've taken a more pragmatic approach to concurrent mode, which isn't a mode anymore, and instead something that you could opt into per component, which is going to be a really welcome change both for application developers and library developers too, as it's going to make it easier to adapt our libraries to use the new React 18 features.
Yeah, I'm particularly excited about server components. I think that's going to open up a new wave of performance improvements. So yeah, really excited to see what happens there.
And I guess I have been using Suspense and concurrent mode for a while, just experimented with it, and some of these bits incorporated into some of our libraries. So really happy that this finally goes out in the open, not experimental anymore.
Yeah, it sort of looks like we're finally getting the things that were announced a couple of years back. So it's going to be again a new wave of innovation in the React ecosystem. So just so that anyone that's following knows, so the way these sessions work is that we all have multiple speakers. Everybody has about 15 to 20 minutes. Then we have live Q&A. Some of these talks they will be recorded, so they are just to make it easier technically, we play them back. But all the QAs, they're live. And if you have any questions or comments, please send us these using a YouTube chat or Twitch chat, and then we will bring them up during the session. I guess it's a good time to go. Move to the first talk by Paul. So let's just move to it and then return to discussion. So here we go with Paul.
My name is Paul Henschel. I'm a Swiss developer. You can reach me here on Twitter. It spells 0xca0a. My talk is called Breaking Out of the Confines, Making Games in React. Also, introducing React Fiber, which will be the means that you use to create, be it games or anything else in WebGL that you could imagine. I guess many people ask themselves, why would you ever want to use React for games? Doesn't seem to make much sense, does it? But let's go back to the core principles of what React is. It's everything but a web framework. If you take it out of any context, just the npm library that spells React, this one has nothing to do with HTML or the browser or the DOM. It just defines what a component is. It says, this is a component, you may use a class or a function, and it can be stateful. In React terms, these are called hooks, for instance. That's why you fetch the hooks from just React. But then you have to pair it with a so-called renderer, for instance, React DOM. And this one teaches React about the platform. This is what these little lowercase native elements are for. You don't import them, you just write them out. And it's not HTML, it's just JSX at this point. But the renderer takes these and then interprets them and expresses it in the terms of the target platforms. And it also teaches React about which elements exist, divs, spans, h1s, and so on. But also says, okay, this is a style, or this is how properties work, or this is an attribute, or this is how events work, and so on. So this all comes from React DOM. It does not come from React. But then, of course, there's not just React DOM, there are actually dozens of them. But let's imagine there's a renderer called React Hardware. It could have something like a diode. Or React Sequencer, it could have something like a track. In React Fiber's case, we do not use divs and h1s. We use meshes, materials, geometries, and so on. Everything that exists in 3JS namespace is available in JSX. Usually you will be writing less code, and in 3JS this will even be more pronounced. Actually, I think it's exponential. The larger your application gets, the more code you will save. This has many reasons. One of them is that React saves you lots and lots of boilerplate. 3JS is very heavy on the boilerplate side. You will be writing like resize handlers, lots of math. The interactivity does not even exist, so it just saves you lots of code. Lessened complexity, because a React app normally will be much simpler, much more readable, and it can be easier to maintain it. This has to do with how code is formed. On the imperative side, if you make a thing, it has to be connected to everything else. Throughout the application, this thing has to be known. It has to be known in the resize handlers, in the updating functions, and so on and so forth. In the case of 3JS, it gets even worse because there's lots and lots of different pieces of the application that have to interact with this thing. There's a resize handler, there's a render loop which does not exist on a DOM, and many other places. React saves you this by forming little independent, self-reliant components. So this one, performance, is super controversial. Always in any case, it generates some weird heated discussions on social because people just don't want it to be true. They say, how can it be that React Fiber has the same performance or could even be faster than 3JS? They think it's unimaginable. It's impossible that this could ever happen. But React Fiber does not have overhead, none, zero. And the reason for this is it does not participate in the render loop at all. 3JS renders, period. React Fiber just manages it. When React is active, that only happens when you construct or alter the scene, the scene graph. That's the only thing when it will flare up for like a millisecond. It mounts a component or unmounts it. But in this, React is actually very efficient and it's virtualized and scheduled. So in some situations, you could actually outperform 3JS quite easily because 3JS does not balance load. The internals a little bit. First of all, native platforms or systems, they can differ a little bit in how they work. For instance, most platforms that you probably know, they are event-driven. Think of Node or think of the DOM and HTML and the browser in general. The way it works is you have a React component, the little thing here on the right side, and it creates something called a view, for instance, a button or whatever it may be. And then there are two phases. One is, for instance, interaction. You can click the button and it will emit a event. This means React is now notified. Something happened and you can respond to it. The second one is stateful. Each component has or may have local state, or you have something like a central state manager. Whenever this state changes, then you can change the view. You can, for instance, disable the button. And in between these two phases, it's idle. Most games have a game loop. A game loop is something that allows the application to respond 60 times per second to something. For instance, you have a spaceship or a cube that you want to rotate or whatever, and you do this by mutation inside the loop. In React Fiber's case, it's the same, but you get actually the benefits of both the declarative side and the imperative side. So you still have the component, and the component, it emits a view. In this case, it may not be a button, but just like this little thing here, it could be a cube. And there's interaction. This is something that's entirely missing in 3JS. There's no interaction at all. All this you have to write yourself, but in 3Fiber it exists. That means you can click or interact with something, scroll it, move it with the pointers and so on. If you do so, it can emit, there's a callback, something happened. And then of course, each component can have local state and you have global state if you want to. But between these two phases, state and events, React is silent. That is the main reason why it does not have overhead. But then there's a means, and we do this by using hooks, that allows each component to participate in the render loop in a managed way. That means if the component mounts, a effect is registered, and inside this hook, you can access your scene graph and you can also mutate it safely. You can spin the cube around, for instance. But if the component is unmounted, this goes away. A couple gaming prototypes I want to show you. This one is called Racing Game. It's being developed by Poimandres. You will find it on our GitHub. And it's open source. Everyone can come and contribute, and many people have. So as you can see, it has vehicle physics, braking stripes, leaderboards, and so on. It's still quite small. It's TypeScript. I think we're using Zustand for state management. Just shows you what is possible. This one is a space shooter. It was the first, my first try making a game. There are no collisions or anything like this. The ship is basically running on a track, but still looks quite nice, and I guess demonstrates how things can be organized into components. And the last one is a super small Minecraft clone. Just knows the ground and blocks, and you have a hammer, you can up blocks, jump around in the first player perspective. There are lots and lots of other examples on the Poimandres site. Just go there, visit the docs, click examples, and you find at least some gaming prototypes that you could either extend or that you could look into how all this is working. Let's create a quick demo application so that you get to see how it all works. We first start by fetching the canvas component from React Fiber. You just put it into your app component. Everything in there is 3JS. So you use meshes, geometries, materials like this. We already have a cube. Let's color it. And you have hot reload, as you can see. All the properties that you see, positions, color, rotation, and so on, they come directly from 3JS. Let's spin this one around, for instance. But I also want to take it out again because I want to show you how to make a real self-contained component. We copy this bit, put in here, and invoke the component. And by doing this, we have already made it reusable. We can duplicate it, adding some props, spread it over the mesh, and now we can put the position on here. I'm going to put this one on the right and this one on the left, like this. While we added, also let's just fix the light so it looks a little bit more three-dimensional. I'm using ambient light and point light. All right, like this. Next, I want to show you how a component can participate in the render loop. I'm using a hook for this called useFrame. Let's make a reference. We put this onto the mesh. Now we have access to it inside the frame loop, inside the useFrame hook. For instance, let's mutate the rotation bit, and you can see all the cubes are rotating, but we can also compose this functionality. Let's take this out real quick, copy it in here, and apply it to a group. I'm dumping the children in there, and now the cube can just be a cube. I can compose this logic, in this case by wrapping the cube into it. And as you can see, this cube is spinning individually. I also want to show you how to create interaction. This is inbuilt in React Fiber, doesn't exist in Three.js, but here you have real pointer events. So you can do on-click, and you can distribute the event state. As you can see, I'm clicking it, change the color. Let's also real quick make the hover state. The handlers I'm going to use for this are on pointer over, setting the flag to true, and on pointer out, setting it to false. And let's just scale it if I'm hovering it and then going back to default like this. It works, you can see it. Let's try something else. You can use, because this is React, you can use anything in the React ecosystem. For instance, let's try to animate it using React Spring, which does not care if it's animating a div or a mesh. If you've ever used this library, you're familiar with this one. I'm taking now the conditions, just put it in here, extract them, and now they're turned to animatables, which I can distribute among the view. And of course you need the a dot syntax, and it's working beautifully. These are Spring physics. The next thing is, because it's so easy to form self-reliant components, the ecosystem is constantly growing. So there's lots of stuff available. For instance, let's just try out orbit controls, putting them in here. You can see I'm rotating the stuff. Now let's take all this out. I want to show you how to use physics, which you really need if you want to make a game. There's a library called Reactive Canon, which is a well-known physics library. The way it works is you dump all the physics objects into the physics components, and now you approximate the shape. We have a cube, so we use usebox. Give it a mass, and now we connect it, run it, and that's it. You can see them falling down. Let's also make a plane to catch them. And the best approximation is a plane, so use plane. The GitHub autopilot just filled this in for me, which is kind of nice. Let's put it in here. Like this, we have to face it upwards, and we have to shift it down a little bit so that it can catch them. And as you can see, it works. We should also change the appearance a little bit so that you can see it, so that it's really plain like this. And let's just change the rotation a little bit. I'm using just arbitrary values here so that you can see them like bounce off the ground. Yeah, okay, this is working. Cool. So we're at like just a couple of lines. It's, as you can see, everyone can do this. It should be quite approachable. I would suggest you head over to the GitHub page of React Fiber. You will find documentation, some hints how you can learn Three.js, and there's also lots of examples. For instance, gaming examples. The thing that we have just made, try to replicate it, and then you could make it into something real. For instance, you will find a prototype that says Arnold. It's this one here. As you can see, almost the same thing, just a couple of lines. We basically just added collision events, and it's looking like this. You have a pedal, you have a ball, and you have collisions. And of course, then you can add stuff. This one is a little bit more involved. As you can see, there's sound effects, looks a little bit more fancy. There's a counter. So there's lots of possibilities. I would say try these gaming prototypes and go and visit our Discord, and you will receive help. I hope you can see that making games is not as inaccessible as you thought. You don't need so much math and deep Three.js knowledge. With React, it can really help, especially beginners, to create something very fast. And from there, you can go on and improve your knowledge. So thanks for having me. And show me your creations on Twitter. Link me if you want to. thanks, and that's it for me. Goodbye.
All right, so let's move to discussion. I think it was extremely impressive what you were showing us. I don't know if you know it, but I have some background in 3D. And then it was like 6 years back, I built a 3D cube. And for that, I built, of course, Web IDE. And for that, I used Three.js and jQuery. So it was a lot of code I had to write for this simple editor. So likely I could do it in 10 lines with what you just showed me. So it's very, very, very nice. Let's see if people have any questions or comments. I think people are really excited about the talk. They like it a lot.
Mm-hmm.
Yeah. So now, if it's a Finnish audience, we don't get any questions. But let's hope there are international people as well. Any comments, by the way, from anyone, any speaker here? What did you think of what Paul was showing us?
I think it's awesome. I really struggle doing 3D stuff, 3D demos. The fact that that's so declarative and so obvious, like I immediately, when you put that plane down, I'm like, you look like you just threw a couple numbers down and then there it was, like really easy. That's really impressive.
Yeah,
oh, wow.
Thanks a lot.
Yep. So we have the first question of React Finland 2021. So is it possible to do mapping applications or maps with this kind of approach? I think that's the question, if I interpret right.
Yes, I think it's possible. There's an open source mapping solution. I forgot the name, and I also think you can integrate it into Google Maps API. I think they share the context.
Yeah. I have seen a couple of these, so we can go. So I think you can do something very, very impressive with this.
For
then
sure.
there's a comment about XState. So I guess you could combine it with XState and make some really nice state machines, state charts, to model the state of your game. Because games, if you think about it, a lot of games are just very, very big state charts or state machines. What do you think of the statement?
Yeah, I think it's 100% true. There's not much difference between, like, I don't know, opening a sidebar, something goes here and there, and I don't know, a car running through a scene. Games are state machines. It's the same thing. The only difference is the render loop. But for this, most of the time you don't use a state manager. You use a state for like flags and level state, stuff like this, and totally XState, Redux, whatever you want to use, you can.
Cool. Yeah, it sort of makes a lot of sense. Then you implement everything from Three.js. So is the API totally complete if you compare what you have there, or is it missing stuff?
You mean from Three.js?
Yeah.
No, it doesn't. It doesn't miss anything because it's not a wrapper. It's a custom renderer. It's the same thing like React DOM. So these elements,
so it cannot.
They are complete.
Yeah. By definition, it cannot miss anything. So it's
yes.
So yeah. Okay. Then there is something about Solid for Ryan. Do you see that coming?
Yeah, I mean, when
Solid Fiber.
When we have a very small ecosystem. When we get around to doing it, I've made some basic 3D demos. Hence, what I was talking about. I've found them very challenging to make. I made a couple simple wrappers, but beyond spinning a couple of cubes, I haven't done very much in the 3D realm. But it's definitely a place we could look at. Yeah,
makes sense. Then any browser proposals on the horizon that would affect R3F? I don't know what's R3F. So React. Yeah. Okay. So. Do you see anything coming in the browsers?
You mean like generally milestones, or in what?
I guess like features or something in the specifications, or I mean we have always the WebGL and then we have something else and this augmented reality stuff and whatever.
Mm-hmm.
I remember that there was some push away from OpenGL, but I don't know if that's valid anymore.
Yeah, it's still going on. Of course, there will be web GPU, but it will still be integrated into Three.js. So we will basically support everything they do, but I'm more like into the React side, so I'm very pumped about React 18, the possibilities this means for us as, for instance, game developers, suspense, concurrency, all the stuff. This is more like our fort.
Yeah. All right. So I think we're running out of steam here. So I guess that was the last question related to this topic. But if anyone gets more questions, as it normally happens, is that you just get it 5 minutes later, so then we can discuss it at the end of the session. So I think it's a good time to move to the next demonstration by David. So let's set up the screen share and discuss XState, or the state of XState. Boop.
There we go.
Yeah. The stage is yours.
All right, thank you. So I am really excited to be here, or not at Finland. I really wish I was at Finland. It'd be a lot more cooler than it is right now over here in Florida. But I want to talk to you about the state of XState. I've talked about XState and state management and state machines a lot in the past. And in the last year, a lot has happened. But before we get into the state of XState, I sort of want to talk about the start of XState and where exactly it came from. So it all started like, I want to say like back when I was a junior developer and I was working for a medical company making a lot of complex forms. And these were forms where it's like you had to show specific fields when the checkbox is checked. And then depending on certain conditions, it might take you to different states or different steps in the workflow, or just invalidate based on async logic. And we weren't using any state management libraries or any frameworks at all. This was back in the time when Angular was just starting to become a thing and Backbone was the most popular library, but we weren't allowed to use any of those. So then I started researching, okay, there's got to be an easier way to do all of these flows. And I think in a very visual way. So that's when I started researching state machines, and I saw that it was a visual language. And I was really interested by this because the flow is very easy to follow, at least for me as a visual learner. But then I decided like, okay, this is very useful, but they're a little bit too limited. So that's when I started looking up state charts. And state charts are an extension of state machines. And in a couple of days, there's going to be a bunch of talks explaining what state machines and state charts are, but they're basically a visual way of modeling your application logic. And I found that state machines and state charts are really cool and useful for modeling the behavior of parts of your application. But it's all about modeling the behavior and not necessarily how different components and things can talk to each other. So I realized that the actor model, which I later researched, that and state machines actually fit together pretty well. And so all of these combined really make up XState. And so when you talk about state management and think about other state management libraries like Redux, MobX, Vuex, or even up and coming ones like Recoil, Zustan, Jotai, all those, I feel like all of those fit into the state management bucket. And what I mean by state management is these are all really good libraries for you have a store for your states and you want to manipulate that state somehow, and you want to do it in the easiest way possible. But there is a need for what's called state orchestration. And so state orchestration is more about like not only state management, but determining how your state can transition over time and what are the behaviors at each of those different points in time, and how do the behaviors change due to events. And so that's where XState comes in. And so XState gives you the ability to know not only what happened and how your state changed, but how your state will change in the future by mapping out all the possible transitions, states, and events that can happen. So fast forward a few years later, I open sourced XState in 2015. Back at that time, it was known as Estado. And I guess almost 6 years later, Now XState is used at many companies around the world, which I'm excited about. I came from Microsoft, but I actually wasn't involved with any part of Microsoft that used XState, but it's really cool to see that they were using that in production. But this talk, since I only have 15 minutes, is mostly about what is new with XState, what's new and what's coming up. And so the features that I'm really excited about that are actually brand new and available today for you to use, one is strongly typed models. So we introduced this, this helper function called create model, where you give it the initial context and events, and these are event factories that create event objects for you. And so instead of calling create machine alone, you call the model dot create machine, and now you're going to have all of your events strongly typed. You're going to have your context strongly typed, all without having to do that really repetitive TypeScript logic and putting all of those generic types everywhere. So if you're using XState with TypeScript, I highly recommend you use create model, because we also have some new things and improvements coming with create model in the future. Another thing I'm excited about is the fact that state machines are a bit of a learning curve, and a lot of you are really used to using reducers. And so now with XState, you can actually use that same logic from your reducers, put it in from reducer, and spawn reducers or invoke them as actors directly in your state machines. So you could reuse the exact same logic and customize it however you want to do. And so reducers are really useful, and these actors are really useful for if you already have existing logic and you want to incrementally move to XState. Now, some upcoming features which are currently in PR right now. The first one is strongly typed actions. So you might notice that we have a new property here called schema, and this allows you to create a schema, either just the type, or you could put some values like JSON schema in there too, and present that as schema to the machine, so that in this case, all of your actions can be strongly typed. Now you could do the same thing with events, context, and in the future with guards and services too. And so the schema serves two purposes. The first is for strongly typing all parts of your machine, which allows for autocomplete and early error detection and things like that. And the second part is, especially if you use JSON schema, you could read that schema in runtime. So let's say you have schema for actions or events. You could automatically generate, for example, forms from that JSON schema based on your machine. And so this opens the door to so many exciting possibilities. So I'm excited to get actions and the rest of the schema in there pretty soon in version 4. Another one that it's a really small change, but I'm really excited about it, is determining whether you could send an event or not. Before, we used to have to duplicate validation logic and disabled, enabled logic. And what we're really trying to do when we're disabling a button or disabling a field is saying, I want to disable this if sending this event will not cause any change, because it shouldn't cause any change. And now it's going to become a lot easier. With state.can, you could just say, hey, if I send this event, will it change anything? If not, then maybe this button should be disabled. So it's just a really easy way to have that improved both developer and user experience over there. And one of the biggest changes too that's coming up soon is deep actor persistence. So with XState, you could persist and restore states, but with XState, you could also spawn actors. And so again, in a couple of days, there's going to be a talk on the actor model. So in coming up in XState, we are actually going to be able to persist these actors so that when you restore your machine state, like let's say you refresh your browser window or come back to it after pulling it from local storage, it's going to attempt to rehydrate each one of those actors at the states that they were persisted. And if you're not able to, then it will just start the actor as new and everything will still work as normal. So that's one of the big features that's coming up, and it's one that's been highly requested. So the XState ecosystem is currently made up of a lot of modules, especially integrations with frameworks like React, Vue, and Svelte, and helper utilities like FSM, test for model-based testing, Graph, which is used to power a lot of our visualization and testing utilities, and Inspect, which allows you to communicate your state machine running in your live application directly to an inspector. We do have a few upcoming modules too, and so these are preliminary, but one of our engineers, Matt Pocock, is working on XState parser and XState CLI. So this is going to give a whole new set of static analysis abilities to your state machines, and it's going to enable a lot of really cool things. And so 3 other things that we're working on too is XState form, XState router, and XState query for all of the common applications that you would probably want to use a state machine for in your application. And these libraries are going to help making the creation of forms, routers, and querying async data a lot safer, a lot easier, and most importantly, able to be visualized. And this is all even before XState version 5, which we're still working on. And a lot of big changes are coming there too, but not huge changes as in breaking API changes, but more just really good quality of life improvements. One big thing, or rather, I should say small thing, is that XState version 5 is going to be more modular. So instead of importing all of XState, you could choose exactly what you want to import. And so this is going to result in a smaller file size. There's also going to be higher order guards, which are going to allow you to combine different guards, whether they're serialized or inline inside of your machine definitions. And this allows the guards to be visualized in some creative ways as well. We're also going to be introducing partial wildcards so that you could say, if my event starts with mouse.something, then respond to it with this transition. And so this allows a lot more flexibility and succinctness in your machine definitions. But yeah, the other big things that I'm really excited to release, in fact, I'm publicly releasing them tomorrow, but you're the first to know about it, is first stately.ai/viz. This is the new visualizer that is a vast improvement to the old one. If you go to xstate.js.org/viz, you're going to see that there's a huge difference between this and the upcoming stately visualizer. So if you visit the visualizer, you can now enter your machine definitions in TypeScript. There's an entirely new layout algorithm for laying out all of the states. And now you could also share your machines in the Stately AI registry. So whatever you create in the visualizer, save it to the registry, and you're able to fork other machines or favorite them or just share them with people so that they could simulate your machines and understand your application logic just by sharing a link. And the final thing that we're working on, and hopefully getting it out within the next couple of months, is the Stately editor. And so hopefully we're going to be having a beta coming out soon for this. And so this is going to allow you to create state machines visually without having to manually code them, or you can manually code them if you want. The main idea here is that we want you to be able to not have to have both documentation and code be two completely separate things. Rather, we want you to have your documentation be completely in sync with your code so that it's never out of date, because that has been one of the biggest struggles from all the years I've been working in various projects, is that we would have all of these nice, beautiful architecture diagrams and logical flows and user flows and everything. But as soon as it gets to the code implementation, those flows quickly become out of date. And so that's something that we're looking to solve with the Stately editor and the suite of visualization and analysis tools that we're going to be introducing soon. And so you could find all of this information at stately.ai if you sign up for the mailing list. And also, please join our community at discord.gg/xstate. And with that, thank you so much, React Finland.
Yeah, thanks for the talk. Let's move on to the discussion and see if you have any questions from this international audience. So, okay, first one. I guess that's more for Ryan.
Yeah, I mean, I talked to David a little bit and played around with it. I've got demos of it. I haven't made like an official integration. Hoping to kind of play with it a bit more of the community, get an idea of what they want to see out of this kind of integration. One of the cool things that we can do with Solid is apply the changes fine grained. So you can update a machine and then like have only certain properties update certain parts of the DOM. So it's all like split out automatically without selectors or anything. So we still got some more research to do, but I'm looking forward to seeing a official integration.
Yeah. Cool. Juha-Matti liked the talk. It was great from my point of view as well. So now we don't have so many questions from the audience. So, I mean, one thing I was thinking about is this, like when you write an application, you write some logic. How much of this logic can be separate from React or Solid or Vue or whatever you're using?
So yeah, that's really the main point of XState, is that your logic is completely agnostic. And we first had integrations with React, and actually that's the one that we spent the most time with, just because React, it's not exactly an events-driven framework or library or whatever you want to call it. So you do have to do some workarounds for that. But yeah, we've seen integrations for Vue. Svelte work really well. It works pretty naturally actually with Svelte and Angular, just because it's a subscribable store, and I'd imagine Solid as well. But yeah, the entire point is for you to have your entire logic framework agnostic, and in the future language agnostic as well.
Yeah, that's cool. And if I remember right, there's some kind of standard for state machines. So just like you can get, I don't know if it's XML or whatever, but you can get some kind of definition out of it, and that's what you can throw around.
Yeah, exactly. It's called SEXML, which stands for, oops, I muted myself, which stands for State Chart XML. And yeah, there's actually a lot of implementations in different languages. So whatever you create in XState, in theory, can be run in different languages, since it follows that spec.
And I guess you have a lot of tooling around this. So when you have standard, and it's like with this testing and other things. And we have a question. Does XState play nicely with other libraries like React Router or form libraries?
Yeah, so the way that XState plays around with virtually any library is XState is, it's simple. And of course, simple doesn't mean easy. By simple, I mean it's completely events driven. So event and state driven, which means if you want to communicate with XState, you do so via an event. Now, this could be, you know, a little bit of boilerplate where you have to convert everything, especially if you're using it in React, you have to put it in use effect. And whenever something changes in that use effect, you're sending an event over to an XState machine. But what that means is that that event, it doesn't matter where it comes from. We don't have to build specific integrations with every single popular library out there. Everything is just an event. And so that's the way that it would work with React Router and other form libraries, and even libraries like React Query, React 3 Fiber. I'm actually really excited to play around with that and make some games with that. But yeah.
Cool. More questions. So will there be any improvements to manage global state machines in XState React without send parent? Maybe a use global machine hook?
Yeah, that's something that the Stately team has actually been thinking about a lot. Is at first, XState was local component first. So you have use machine, which is just like use reducer. You put them in your individual components. But we were thinking like Redux's idea of having a global store is actually useful, because you do want data shared with a lot of components. But we don't agree with the whole single global store idea. So more, it's like a global system where you have stores that communicate with other stores. And so components can subscribe to any of those stores in the global system. And so, yeah, look out for that soon. We actually merged a PR recently that's going to be an important fix to getting that working.
Yeah, cool. Next one, does it make sense to think integrating XState with MobX State Tree, or are there overlapping solutions?
I think MobX State Tree is cool, and there were some people who did look at integrating that with XState a while ago. I'll have to experiment with it more, but I think what we're doing in XState very much mirrors what MobX State Tree is doing architecture-wise. So there might be some overlap.
Yeah. I think we're running a little low on questions. If anyone gets any questions, just push it to YouTube chat, and we will get back to it at the conclusion of the session. Just to mention, we have later in React Finland this week, we have one session just about state machines and state charts, and you will learn about actor models and all that. So if that's interesting for you, just show up. I think it was Wednesday, if I remember right. So since no more questions show up, I guess we should move to the next one. So Ryan, are you ready?
Yep.
All right. Let me find the right clip. So it's here. Live coding. Intense typing.
Let me know when the screen shows because I can no longer see because I'm in presentation mode.
Yeah, very moment. It's I don't see it yet, so I think you have to share the screen again.
Okay.
But it's fine.
Okay.
Yeah, it's fine.
All right. Let's try this.
Yeah, good? now it's there. So here we go.
All right. I've already been introduced, but my name's Ryan, and I work on SolidJS, declarative JavaScript UI library. Yes, this is another JavaScript framework. So you might be asking yourself, how did we end up with a talk about a different framework in the opening of React Finland? Well, the reason for that is that Solid is a very React like framework, right? At least on the surface, right? We are all about unidirectional flow, read-write segregation, immutable interfaces, and it's built on a lot of the same building blocks. We have simple primitives, they're hook-like function components and JSX, and really a lot of the same features. Portals, fragments, context, suspense, async, streaming, SSR, concurrent rendering, the huge list of things, right? But there is a but, and it's a rather large one. Solid is sort of nothing like React. It's built entirely on fine-grained reactivity. This is similar to MobX or Vue, and its components only render once. I'll explain what that means a bit further along. And there's no virtual DOM. Basically, the whole mental model is completely different. Solid shares a lot of the same values, but it's an entirely different implementation. The way I kind of like to think about this is a bit like Black Mirror or one of my favorite 90s shows growing up, which is Sliders. They spent each episode traveling to the current date in an alternative realities where some critical event in the past had changed the present slightly. And that's sort of how I view Solid, right? How different would React be if a different decision was made at the beginning? I've been looking at this pretty much as long as React has existed, although I didn't really start working on Solid till about 2016. But we don't need to go back that far. I actually just want to go back to the first time you saw React hooks. Just kind of get that back, reset your mind back to that point, right? Maybe it was October 2018, maybe it was a bit later, but we're gonna start there. So let's create a counter. The kind you see on every landing page, every intro example. Naively, when you first saw hooks, you might have done something like this. This has more than a few problems. Mostly though, it's that we set an interval here that updates the count. And as you can imagine, every time it updates the count, it re-renders our counter if this was React. And we create a new interval and these start stacking and who knows what you're gonna end up with, honestly. And your browser might eventually run out of memory. So what do? Well, we use effect, right? That's what it's there for, right? Now we have, cleanup. We can clean up on each execution. And at first glance, our counter would work properly, right? But there's a problem. If other state changes in the component, it actually resets the interval on every re-render. So it won't be uniform. If some new props come in or some other states in your component, you'll get kind of jagged, inconsistent delays depending on when the other state updates. There is a solution for this, and most people know you just set the interval once, right? We have a dependency array here for a reason, but this has another interesting result. Our counter will start at 0, and then it will move to 1 and never update again. And the reason for this is we have a stale closure wrapping over the count at 0. So every time the interval is called, it just sees count as 0, adds 1 to it, and resets count. we can use the function form of React to actually set the count, but this doesn't account for things like fresh props. And honestly, I didn't invent this example and this progression here. Some people found it in the wild, but Dan Abramoff actually wrote an amazing article called Making Set Interval Declarative with React Hooks. And he kind of goes through the next couple hiccups rather, that happen throughout this process of extracting this into a reusable hook. But I'm just going to, for the sake of time, skip to the end. There's a bit more code here to get on the screen, so hopefully you can still see this. But the gist of it is, through using a ref, we can store the current callback, and that encloses the latest value of state. And then we have our solution. Essentially, every time set interval is called, it can use the new callback, and that will then see the latest state. And when we add one, it will update. But I want to say, look at where we started from and where we ended up. This comes from the natural impedance mismatch of imperative use interval versus something declarative and pure like a React render function. And the thing is, once we encapsulate this off, into its own hook, it's really nice to use. But why spend valuable minutes of a presentation showing you React hooks fundamentals when I could be showing off Solid? Well, what do you think this example looks like in Solid? Yeah, we're back where we started. I mean, there are differences. I never claimed Solid is the same as React. Instead of state, we have signals. The value returned is a function getter that retrieves the internal value rather than and makes through reactive descriptions rather than just the value itself. And we use things like create signal or create effect instead of use to signify that it's only created once, because a component only executes once in Solid. But this example in front of you works perfectly fine. That is all it takes to make this counter. And okay, I'm a bit irresponsible here, so let's add some cleanup, because if this component ever unmounted, we would like to remove the interval. But here's the thing. A lot of compile frameworks, like Svelte or Marco, pride themselves on allowing developers to write less code. But I'd argue it's more than the syntax, that makes these libraries have less code. Sure, you type a few less characters, but it's actually the reactive execution model that enables this. No need for use ref, no need for use callback. But I mean, this is pretty different than React. You're probably wondering a bit how this works. So let's see if I can show you what's going on here. So I'm going to open up our playground here for Solid, and this is our same counter example that I just showed you guys. Now, I've got the console open here so you can see quite quickly what I'm doing, but I'm just going to console log something. What you see here is hi gets written to the console once, and our counter is still updating. And this is because in Solid, it's not the components that re-render over and over again. It's actually the hooks, so to speak, right? If we wanted to write this out lots of times, we would, create effect, which is our analog for use effect. And even then, while this will print out this log, it's still only doing it once. And the reason that is nothing has changed, right? This does not depend on any value that's changed. So let's make it listen to count. Now you can see that in our console, it's actually counting up along with us. The way it does this is very similar to how MobX or Vue works, in that we are dynamically tracking the access of these signals at runtime, which is why we use functions here. So I'm gonna show you a bit more how this works. Okay. This is getting a bit more into the technical details here, but you can view this as a global stack where we keep track of all running effects. Every time an effect runs, it pushes itself onto the stack so that it can be subscribed to by any signal accessed under that execution. That way, whenever a signal's value updates, we can just have it call that effect again. And when it's done, it then pops itself off the stack. Beyond that, we just need the scheduled effect to run the first time, so dependent signals can add it to their subscriptions to kick off this whole process, right? As I've mentioned, this is very similar to MobX or Vue. So if you've used those, this should be familiar. In any case, we don't need dependency arrays with this approach. And this mechanism is completely independent of any component. In fact, in Solid, components are little more than the functions you write. And they don't actually own the state themselves. All right. So I pose a question. What if we used effects to update the DOM? All we need to do is get our JSX to compile just a tiny bit differently. Well, maybe not that tiny. What if our JSX produced real DOM nodes? Right? Here, I'm just using document create element to create this H2. But if we do that, then updating count only needs to rerun this one function. No component execution, no diffing, no reconciling. Just set the new text content on the text node, or sorry, in this case, the children of the H2. Is it any surprise why Solid's so performant? Solid gets a lot of attention for being a benchmark winner, but I hope to show the simplicity here along with the fact that this brings near vanilla JS level performance. What we have here is basically just a state library. For some old timers here, this probably sounds a lot like JavaScript frameworks that predated React, things like Knockout.js. I love Knockout.js, but I also love React. It took me years to break out of my old patterns to appreciate React for what it was. It's a philosophy more important than the implementation. Not that React is going to adopt what we're doing here with Solid, but I want to show you that things are a little bit different this time. And that's for 3 reasons. And the best part about it, you don't have to trust me on this. I didn't even invent any of this stuff, seriously. MobX has shown the guarantees we need to make a reactive system ensure that it stays glitch-free, to ensure our updates propagate in an effective and predictable manner. If you've used MobX, you've seen this, but it makes sure that every single computation only gets run once, runs in order, nothing gets out of date, and keeps everything consistent. We have the same thing here. A little lesser known reactive library, SJS, showed that by registering our effects within parent effects, a nested reactive system could automatically clean up after itself. This solves a significant problem we have here with the observer pattern, where it actually frees up stale observers automatically. See, I asked a minute ago, what if we used effects to update the DOM? But a better question is, what if we view all rendering and hook creation as a side effect? Let's explore this for a minute. I'm going to come back to scheduled updates in a few minutes. So this image has been known to give some React developers headaches. Hook rules have kind of preconditioned our minds to reject this sort of nesting. But I just wanted to kind of put it out there that if you can onion or nested effects, we can basically create a hierarchy independent of any components. It isn't unlike a component tree. It just isn't defined by how the developer breaks up their code, but how the application itself is actually structured. The key to this is that it's only the nearest effect where the value is read that reruns when the value changes. We use this by using the function, the getters, the proxies to lazily evaluate everything. As I showed in the previous slides, when we update, say, signal D here, it's only these effects that rerun. But if we update A, we actually end up running everything inside the second internal create effect here. This might be a little bit hard to visualize, and I understand that, but you could almost see that this structure of code could be generated from like this application code. Notice in our app component here, A signal kind of determines whether or not we render the child. And that's very similar to here. That's the only time it needs to reevaluate is if, you know, we change whether we are going to display the child or not. And then from there, the rest of the effects here are either, you know, user-written effects or, you know, expressions that you find in the JSX. The takeaway here is there's not much in the way of a rendering system. The whole thing is built with the same reactive hooks that any developer that uses Solid would use. And that brings us back to scheduling, which is something we borrowed from React. React has this sort of 4 stages of render thing going on. First, you have that event, you know, where the state updates. And then you have basically the pure computations that you know, update the render functions, right? We've all seen this equation before. And then after that, React takes the VDOM output, diffs and patches it. And then, you know, when it's all updated and the DOM is updated, it runs your user effects. On the Solid side, it actually isn't that different, except it's hooks that govern this lifecycle, right? We still have our event. And then our pure computations are in the form of create memo, which is our analog to use memo, more or less. And then create render effect. End users don't usually write this. This is what the JSX generates. And then finally, are end user effects. And that's the thing to kind of realize here, right? We are more or less have the same kind of execution pattern of event, pure computation, and then side effect. So we have the same ability to hold off applying our side effects. This allows Solid to do things like concurrent rendering or transitions. So what are we dealing with here? Like, what are we dealing with Solid? Is it an implementation? Not exactly. I don't expect React would ever really follow this path. There's enough differences in the execution model, right? Solid is not a React clone. It's, there's no React compat. It's not like Inferno or Preact. The execution model, it really is that different. Language? Not really. We're not really trying to make a completely different dialect of JavaScript. This isn't Svelte or Marco, whatnot. It's just your JavaScript that runs. We only transform the JSX. What you run is what you get. So to me, it's a paradigm, right? And it's just simply reactivity. That's all you get here, right? And we can apply that paradigm to whatever we want. For example, if you don't use a DOM element, we don't need to pull in any DOM code. And this means, we can look at stuff like native, as easily as doing suspense on the server for SSR, or maybe spinning some 3D cubes, or, and this is just a communication mechanism. So, and synchronization means, so use however way you want to organize your data, right? How about state charts, right? We just had a nice talk on that. And really, as I mentioned on the previous slide, why not use transitions or concurrent rendering? This is all tools at your disposal. It's just how you model it. And that's what reactivity does. It lets you model stuff, right? You basically have a low-level abstraction over the simplest of primitives. So, as I said at the beginning, I like to think of this as one of those alternate realities. What if the early developers on React had, instead of looking at improving upon Angular's dirty checking, looked at something like Knockout.js, right? They might have arrived at something kind of similar to what we have with Solid. So, we're still a small ecosystem, even if I've been chipping away at this for many years. But I hope, those of you who are interested to kind of explore, take on the adventure, could, step through the portal and see what's available to them, so to speak. Thank you very much.
Yeah, thanks a lot. I think it was a great talk. And we move to the discussion. So let's see if people have any questions or comments on YouTube or Twitch. So I have to, and now. Signals. I guess that's a good summarization, because I think as far as I understand, signals, they simplify a lot, or they get some complexity out that you want out. When it comes to signals and what you develop, do you still have to worry about keys and memorization and all this, or is it all in the paradigm itself?
Exactly. When you saw me layer this stuff, and I realized I got a little technical, it's always hard for me to really explain the differences without some of the kind of technical stuff there once we get past that set timeout example. But the actual tree is almost naturally memoizing itself. Like, essentially the layers, the onioning, is just a form of memoization. So for things like for loops, we have special helpers, and they just execute only the parts that need to execute. We basically apply this fine-grained approach to everything. And
so let's say you have a React application and you decide, I'm going to try Solid. So what does it look like when you start porting away from React to Solid? Do you use them like side by side, or what's the porting process?
Yeah, I mean, on the surface for your simple components, it'll pretty much just slide right across, right? But obviously, places where you're using use callback or use ref, there's no real need for those. So there's no, you have to kind of rethink stuff. And I think that is the trickiest part for React developers in terms of learning Solid, is that the mental model is different. It is closer to something like Svelte to a degree, but it's actually all runtime. So it just takes a little bit of knowing, this is a signal, not just a value, right? It's not just top down running. It's event based, more or less.
Mm-hmm. Yeah, that's really cool. We have a question. What will be the trickiest parts of SolidJS for a standard React developer? How is the learning curve?
Yeah, the concepts are the same. The API is very similar. That's a positive and a negative. The positive, as I said, is when you start doing the simple stuff, it just kind of works. The negative is you might not read the docs or do the tutorial or whatnot, and kind of find yourself with slightly the wrong mental model. Basically, the biggest, and this is as far as I know, the gotcha here is since we're lazy evaluating everything, where you access your data matters. Most of the time, this has no effect because you generally access your data where you use it. But like MobX or view setup function, you have this scenario where, if you prematurely destructure props coming in, then you can lose reactivity. And I think that's really the one thing that time after time catches developers. Once you're going to go, don't destructure props coming into your components, the rest of it kind of just flows together.
Then there's a question about performance. How does performance compare to something like React?
I try not to talk about this too much, but Solid's performance is pretty impressive. In terms of benchmarks, in terms of any kind of thing you look at, I don't want to kind of drill too much into it because there is some truth to the fact that performance doesn't matter that much, but you'll see that in most benchmarks, Solid is way out in front of most frameworks, and it is very it's closer to vanilla JS than it is closer, say, to React.
So how about the size of SolidJS?
It's generally speaking pretty aggressive tree shaking. For small apps, something that's Svelte is still smaller. They put more code into the components and less into the runtime. But I found that the tipping point of that is about 3 to do MVCs, essentially in size. So once your app gets about as big as Hacker News, Solid starts being smaller than Svelte in terms of size.
Yeah, that's a very interesting point because there's always some cost to this compilation and all that. So let's say you're a React beginner. How do you use SolidJS? So
Yeah, I was going to say, just go to the website, play around the tutorial. There is also like a SolidState library for React if you want to play with it, but I don't feel that gives you the full impression. I think really we have our REPL, we have a tutorial very similar to Svelte, inspired by Svelte's tutorial. And I think that's really the easiest way to kind of get started and just kind of play with it. The solidjs.com website has that all linked up in there, and you can just try different stuff.
Right. So head up to the website and then start doing stuff. Makes sense. How does the term concurrent rendering make sense here when you directly update the DOM? Do you somehow store effects to apply?
Yeah, actually, the truth of the matter, this is all queuing and scheduling behind it. One of the biggest innovations, I guess, with Solid on this side is that the reactive, like React has fiber internally, so you have all these fine-grained little updates. Solid's hooks are already fine-grained. So we can just go, oh, this is an effect, and you're in a transition. Just stack those off and queue them when the pure computation part is done, right? We do the fetching, like say the resource fetching, as part of a pure computation, and then we wait for it all to settle, and then we apply it. And it's a little bit more complicated than this, obviously, but essentially we fork reality on the pure computations, and then as new updates happen, if they're under the transition timeline, they just apply to that transition. But if they're outside, we can actually apply it to both realities. And in so, we can actually have multiple realities rendering at the same time. And then when the time comes and everything settles, we basically replace the current reality with the transition reality and apply all the effects.
Yeah, let's say it's impressive because I think one of the hard parts in React is always like animations and transitions and dealing with this stuff. So it's great to hear that there's let's say there's an alternative solution. Are there any plans to create something equivalent to Next.js or SvelteKit supported by the core team?
Yeah, definitely. Already in works. It's called Solid Start. I'm going to say it's an alpha, like it's in alpha. I've broken it, I think, 3 times this past week. So like, seriously, don't really use it. But if you want to try it, you can. It's basically very inspired by SvelteKit. Again, take a lot of inspiration from that. It's based on adapters, uses Vite, has, file system based routing, supports streaming SSR out of the box, basically, and works on different platforms like Cloudflare and whatnot. That's basically the plan here. It's going to take us months, realistically, to get it to where it needs to be. But yeah, we're already working on it.
Yeah, that's cool. And I have a nice comment. So Jorge, hopefully I pronounced the name right, thinks that SolidJS is accomplishing what any new React libraries want to achieve, which is to render less. And then SolidJS goes one step above this because it's rendering only one time. Or like, let's put it this way, that it's impressive what Solid is doing rendering wise. So,
thank you. Took a while to get here. Recently, there's been other people seeing what we've been doing here, and the truth of the matter is, GSOL is just a state library. We've seen some great work being done by even like Daishi, who works on Jotai and stuff, and just playing around with a lot of similar concepts of just taking a state library to render without React. There's a lot of gotchas and caveats I've learned over the years. So I published the core of Solid actually as a framework, as a reactive library independent module called DOM expressions. But I'm super stoked that this has kind of spawned people into kind of thinking about how to approach state and rendering like in a completely different way.
Right, cool. And does Solid have UI components or widget libraries?
Yeah, basically 1.0 went out, I guess, 2 months ago now, and this has kind of been the calling point to kind of consolidate on the ecosystem. Before, there's people kind of playing around with stuff, but we didn't really have much of an ecosystem. So I wouldn't say that today I have the components to just push on to you. There's works on core to carbon components, headless UI. Come to our Discord channel. You can see the activity going on. There's a lot of work in progress going on right here. Even though I've been working on this for a long time, I really feel like this is the launching point in terms of building up the ecosystem.
So related to this question, do you have experience with something like Tailwind? Because they have a lot of UI. They have a lot of sort of starting points for components. So do you have people working with Tailwind that just take their ideas or UIs and port them to Solid, or? Yeah,
definitely. I mean, there's certain things that we get for free with our tooling using JSX and whatnot. And I know that people have been working with Tailwind CSS in some of our starters. There's Windy CSS. There's so many different compiled options. One of my favorite things, though it's not Tailwind per se, is Vanilla Extract, which is this compiled TypeScript styling solution, which has basically zero runtime. And because we use the same tool chains, there's a lot of opportunity to actually use this stuff with Solid, even if we don't have React execution compatibility. Just like dealing with JSX or having like simple ways to insert it, it's that part is almost the same patterns. So yeah, I've seen some really cool demos with Tailwind, for example, but there's still a lot of noise from the early community just throwing library ideas out there and people trying them, right? It takes a little bit for these different things to gain traction.
Yeah, speaking of Vanilla Extract, we have a demonstration by Mark on Wednesday. So if somebody wants to learn what it's about, it's a good chance to do it. And then I guess this one, somebody is waiting for Material Solid.
Yeah.
So I guess that will be one way to solve it, because if somebody writes a wrapper, then
as I said, come to the Discord if you want to work on this. Come on over. As I said, there's a few of these going on, but yeah, I imagine in the next several months we'll see a larger growth. A lot of interest has kind of been renewed or shown up for the first time now that 1.0 is out.
Yeah. So if anybody has any more questions, now it's the time to do it, because otherwise we move to the demonstration or presentation by Travis. It's sort of silent, but of course we can discuss more at the end. So I think we move to the next one. Stuff to find. Live demo or presentation. And
hello, everyone. My name is Travis Arnold, and I'm a designer developer currently working on the design systems.
I have to start it at the right point. Sorry about that. Here we go.
Hello, everyone. My name is Travis Arnold, and I'm a designer developer currently working on the design systems team at Frame.io. Today, I would like to talk to you about empowering more people to write UI for any platform using JSX. To preface, most of the code I will show today is still very experimental, and there aren't any official docs or published libraries yet. First, I want to start with the current state of design handoff. Very few designers currently work in a medium that will end up in production. Many tools attempt to abstract design aspects into code, but fail to expose a declarative model that can be used as a source of truth. These tools are fantastic for doing illustration and icon work, but break down when we can't easily mix code into the process. Plugin systems available in these tools allow for writing code, but leave much to be desired. If we look at a typical workflow between teams, there's an inherent disconnect in our process. A designer creates something, making hundreds of decisions. Then the work is handed off for a developer to implement. Finally, we ship an end product to production. Basic information about primitives like layout and hierarchy must be accessed imperatively and translated. This causes duplicated work and results in sources scattered across multiple tools. Not to mention, it's a waste of valuable time. These decisions are encoded in one way or another, and we should be able to use them easily in the final product. So how do we fix this broken process and allow for proper synchronization between design and development? I think compilers might just be the answer. In the front-end community, we use compilers for everything. Babel, TypeScript, Prettier, ESLint, and soon the standardization of all of these tools in Rome. These tools help us be more efficient. We can enjoy new syntax features and compile them down to something browsers currently understand. In React, we've seen how even if the language doesn't offer a feature, we can utilize linting to guide how an API is supposed to work, as hooks work today. In a sense, compilers are liberating. They can take the burden off of API decisions, we can use code mods to rewrite an entire code base with new features, or help direct newcomers and teach them how our code should work. Similar to how compilers help us write code more efficiently, they're the perfect tool to help us map design to code. Other libraries like Svelte and Vue rely on compilers. How might we benefit from them in React as well as in design? Using static analysis, we can use the information from props to compile from one JSX source to another. One thing compilers can be good at is static analysis. Static analysis is the ability to determine how your code works without executing it. Using TypeScript as an example, the compiler provides rich information about the contracts we set up in our code, giving us the confidence to iterate quickly and easily. JSX specifically lends well to static analysis, depending on how it's written. Where we suffer most is we're free to do whatever we want when writing React. We can interrupt JavaScript wherever we see fit and pick various styling implementations. This causes problems for static analysis and keeps us from practically writing cross-platform code. By driving everything through props, we can open up a whole new world of possibilities. This brings us to style props. In almost every design tool, layout and style tokens are first-class concepts. Manipulating dimensions and space are done directly on the layer, and styles for that layer can use predetermined system values. However, for developers, each platform has a separate way of handling styles. Sometimes styles can be completely disconnected from the implementation, making them hard to reason about. This is where style props can help. Style props are simple prop definitions that control the styling of an element. By moving styling concerns to style props, we can get a better snapshot of the overall intent of how a component should work. Did you know? HTML3 had a form of style props. However, because the web was primarily focused on content, CSS became the standard way to target multiple elements for styling. Thus, style props were deprecated. Style props have excellent ergonomics. They're easy to get started with and quick to prototype, and can later be taken into production. Not to mention the concept maps really well to how design tools work. Designers work with high-level primitives already, drawing something like frames or text elements onto a canvas and setting props for the sizing, color, and other respective attributes. While styling isn't the only concern, how can we include systems like tokens, transforms, and variants into our props? To achieve that, I'd like to introduce you to a concept I'm calling compiler components. Compiler components marry design and development. allowing both disciplines to work cohesively together across any platform. This is done by using well-defined prop boundaries that can be statically analyzed, providing a rich source of truth for layout and styles. You can get started with compiler components quickly by using the create component function. This function accepts a configuration that describes how your component works across various platforms. In most front-end systems, we deal with the same problems: themes, transforms, polymorphism, variants, assets, and overrides. Although a bit meta, let's see how compiler components allow for best-in-class performance and developer experience. Just a note that overrides are still a work in progress in the overall system. However, we will see how we can use overrides when dealing with assets. Compiler components can configure a theme, allowing any prop to interact with your design system. This can be used during static analysis to get an overall picture of how your system is working. Sometimes you want to prototype things really quickly, or maybe you genuinely need a one-off. This built-in system allows you to work swiftly and track how your tokens are being used. Let's look at how we can map values to tokens using transforms. Transforms determine how prop values are mapped. They return an object of one or many values and work great for defining custom implementation details for your specific setup. Next, we have polymorphism, which is especially significant for accessibility when working on the web. We can use an as prop as popularized in recent React libraries to swap out the underlying element so our final output is semantic. Variation is inherent in UI design and development. The first-class variant system can be tailored to your needs when creating a compiler component. These are known as component and prop variants, respectively. They use transforms and can even influence the final rendered element through polymorphism. First, we have component variants. These are the standard configurations you may use throughout multiple props and are configured when defining your components. By using a compiler, we can effectively render optimized code for each platform. Next, we have prop variants. These are slightly different and don't require configuration, but rather allow setting different prop values based on theme properties like breakpoints or any Boolean value of your choosing. Again, using a compiler, we can optimize the component for the platform they are rendered to. In this first example, we can easily switch to a larger font size as the screen expands, targeting the tokens we previously set up. Next, we can see an example utilizing Boolean values to toggle an active background color on and off. When we get to asset management, things get really interesting. We move away from create component and instead utilize two global components, graphic and layer. These are responsible for communicating directly with your design file to extract assets. The graphic component allows us to quickly grab assets from a file, allowing further modification of props. When you want to target specific layers, you can use the layer component to add additional props or use the power of polymorphism. In this example, we swap out the children for framer motion components, allowing us to animate them. Once an asset is in its final medium, we almost always need to make adjustments. We should be able to morph and tweak things instantaneously until we get the desired result. For example, the intro slide you saw earlier, I actually went back and tweaked my illustration after seeing it in the final medium countless times. Evolution is the difference between a good and great product, and is essential for the creative process. You should be able to hop on a quick call with your coworker and make on-the-fly changes, focusing on working together rather than tools getting in the way. UI should be as easy as possible to create and alter for both design and development. You can take this as far as you want to go. Imagine automatically getting an optimized icon set, using symbols for static SVG, and inlining markup only when you need granular control. Or you could fill out the description field in your Figma component, for instance, and use that as alt text. This creates a highly fluid channel between the designer and developer. Each person can iterate quickly and come to a resolution in minutes rather than hours or even days. This current implementation is only possible in Figma, but you can imagine if Adobe XD or Sketch ever offer a public API, we'd be able to easily change that implementation detail. In light of GraphQL, we can have a design graph, as Brent Jackson coined. Writing our components at a higher level lets us swap out underlying libraries, optimize code, and evolve our systems better. Next, we'll see how all of this sets us up for cross-platform development. SwiftUI and Jetpack Compose show that tools are heading for cross-platform development. Compiler components solve this issue in a performant manner for React. Because we have firm boundaries for how our components are supposed to work, custom visitors can be provided to determine how components are rendered to any number of platforms. As you may have seen earlier, our configs can define specific props and alterations for the platforms we're targeting. There's still a lot of work to be explored here, especially with asset management. It's now trivial to swap out the Web SVG visitor with a React Native alternative. The overall goal is to get up and running with your chosen platform by quickly understanding the core system. So what are some of the benefits of compiler components? They interact with your design system by default. They're cross-platform code for any target, native, CLIs, Figma, Sketch, and it's prime for MDX content creation. It's also implementation agnostic. For example, we can change to styled components or emotion, or even Bootstrap and Tailwind. We also can start to generate reports about our components and do linting to understand how our systems are being used. This also offers a best-in-class developer experience and user experience. We can get up and running quickly and prototype things, take them to production, and ship performant code. There are implications, however. Not everything can be compiled. Components that deal with child manipulation and other dynamic settings sometimes can't be analyzed, but that's okay. It's also harder to debug. At least right now, debugging is more challenging because we compile our code to a different source. We should be able to at least offer hints or offer additional tooling to help with this. Also, if you have an existing system, which you most likely have in place, we can use whatever underlying implementation we desire, like your favorite CSS framework, like we mentioned earlier, or a CSS and JS solution. Again, we can swap out these implementation details as needed. So why is this all important? It offers consistency, which makes it easier to scale, learn, and onboard new users. It also allows us to focus better on tasks that we have to do, like accessibility and animations. It's also fully declarative, which is liberating to express yourself rather than worrying about your tools. It also allows you more full concentration on your message or performance or the next big idea you have. Instead of a gap, the goal is a pit of success that anyone can enter into, not just design and development. Compiler components are future-proof. By keeping practical constraints, we create room for new opportunities. And by starting with code, we ensure that there will be a great editor experience built on top. Similar to how libraries like Next.js allow us to interop node development into our front-end code, I see compiler components enabling designers to truly interop into the development process. Leaning into compilers more allows us so many benefits. As David Khourshid showed earlier, you can imagine a really great workflow when this is paired with other solutions like state charts. Design systems are about people. Enabling better tooling in our ecosystem allows us to empathize with one another better. Thank you so much to the open source community. The talks we saw earlier and the rest of this week will all take a lot of time and energy. Thank you to all of the organizers, presenters, and open source maintainers. These are a few of the projects and many more that have helped have inspired this librarian talk. So what's next? This is the tip of the iceberg. There's so much more to do here to get a better experience between design and dev. Handoff will exist until we can mend our tools into one another. Imagine the future you open your tool and seamlessly transition between code and design. You can focus on your own work while utilizing the requirements and strengths of other disciplines, allowing for more meaningful work. Cross-platform, at least right now, means anything that React can be rendered to, but in theory, we'll be able to support anything that generates JSX. Again, this is all still really experimental, planning for a stable release in the coming months. There are currently no docs and plenty of bugs, but you can follow along with progress at jsxui.com or my Twitter if you're interested. Fun fact, this whole presentation was made with the compiler in Framer Motion. Every demo you saw today was actual output from the compiler, and you can view the slides on the JSX UI website. Please note this site is currently only optimized for desktop use, and I plan to optimize it for other devices now that the compiler is working. Also, I'm testing spacer components extensively, so there's currently a lot of DOM generated in the presentation that I'm excited to try and optimize. Suppose we can write our code in this structured way. In that case, we might not need to render to the DOM one day. We can switch to a new protocol built for application development. Perhaps we're mixing and matching Canvas, but you're none the wiser. Thank you.
Yeah, thanks a lot, Travis. And I guess we move on to the discussion. So, yeah, exactly. How was the presentation created? So you just responded that, but yeah.
Yeah. ScreenFlow is what I used, and so you just crop you can record yourself as you record your screen, and so I cropped it to a circle and stuffed it in the corner there.
Yeah, there's somebody really excited about this JSX. So I think it can be really a good intermediate between designers and developers, because instead of getting this, like in the worst case, you get screenshots from your designer, and then you go and you tweak the pixels. That's sort of what you don't want. But if imagine you get JSX, then you just put JSX to your editor and go. So you don't have to work too much on that, at least.
Yeah, exactly. Yeah, so to really have like a source of truth there where a designer is manipulating JSX whether they know it or not is kind of the goal there.
And I guess it goes the other way as well. So as the developer, you notice, that can be better, or I should change that. So maybe it can map back to the design tool as well. So the developer goes and changes something and gives the JSX back to the designer, and the designer can do their thing. So yeah, that will be the thing. Let's see if there are any more questions or comments. Yeah,
exactly.
We don't need to. And of course, with tools like Figma, we have this concern of how to deal with mobile or responsive layouts. So that's sort of how do you solve it? Because you have to. It's not like you design for print, that is one size, but then you have for the web you have to consider different sizes. How do you deal with it? I mean, what's your approach for it? What do you think of media queries against content queries and this kind of stuff?
Yeah, so I think that's personally where we should lean more into code, and maybe Figma one day is able to handle those kind of things, but I really see design tools as more for illustration and icon purposes, because I think they really shine there, and treating and actually being more in code and using that as a source of truth somehow, whether that's using like the React Figma package, for example, or React Sketch from React primitives, and being able to render that directly to Figma and using it as a source of truth. I think there's still like a lot to be explored there.
So what are your plans for JSX UI next? What do you want to do next, or like what's the release plan, or?
I think definitely getting to some sort of alpha release. Most of the compiler was written in the last like 2 weeks, and so it was kind of all the ideas I've been working on over the last couple of years and trying to get those out. And so trying to get to that, and then I think building an editor on top of that will be the next goal. So I wanted to start with code and then try to see how building like a tool, like a sort of design tool on top of that pans out. Just because, starting with code first, I feel like you're in a good spot. So we'll see how it goes. Yeah,
I guess we can move to more generic discussion. So how do you see JSX UI working with Solid or XState? Do you see interlaps or overlaps between different tools?
Yeah, definitely. And that's my hope, leaning into JSX, kind of like Ryan even mentioned, right? Like you can write JSX in Solid. So my hope is that these things could translate to any number of platforms or even frameworks possibly. And I think it pairs very well with things like XState as well. So kind of showing how those like variant props with like the Boolean logic, you could see placing like those XState like Boolean functions in there.
Yeah, it's sort of, for me, it feels like we start having the pieces of the stack of tomorrow in our hands. So we sort of know how to deal with state and state transitions and then we know how to deal with rendering, and now we know how to deal with styling or design. So we sort of have the piece of the puzzle together, where somebody has to put the puzzle together, like somebody has to get the puzzle done. So we start having that very nice technologies, and I guess if it goes like this, we're developing in a very different way in a couple of years. But that's just my feeling.
Yeah, that's definitely my hope. I want to, kind of like Paul showed, like we can build a game. You can just kind of pick up these technologies and get going. At least for JSX UI, the goal isn't to be like an end-all be-all solution, but mainly those in light of like React primitives, you can take a text element or stack or these simple primitives and enter into the platform of your choice. So if you want to build a game and you need to build a UI in your game, you kind of already know how to do that. So yeah, it's kind of the goal.
How does accessibility and stuff play into your planning here?
So that's mostly, like right now at least, it's through that variant system. So I didn't really present it, I think, maybe too well, but as far as like having a heading 1 variant as an example, we can, once it's rendered to native, if you're rendering to React Native, we can mark those things as like the accessibility role header. So we know once it gets to native, that variant will be accessible. When it's on web, it uses polymorphism to render an H1 tag, things like that. But we can write this like generalized solution that's hopefully easier to write tooling for even. So.
Yeah, I mean, one random idea that just came to my mind are code mods. So I guess you could start writing something like code mods for design. So you have an app, and then you realize that I have to change this one thing, but like, does it make sense in terms of JSX UI that you will write tools to make transformations to what you write, or this compiler approach? Is there some kind of overlap between code mods and JSX UI?
Yeah, exactly. I think even like GPT-3, like there's some probably really interesting things there. Once you have those tight boundaries around code, you can do generative design and think of painting all of your screens, like, and just generating through them sort of like components.ai, if you're familiar with that. Yeah, I think there's a lot of room for opportunities there.
Mm-hmm. That's really cool. So I guess it's good to discuss some takeaways from the session. So what did you learn, or what did you think? Was there something new for you, or maybe do a little round? So Ryan, what were the things for you that you picked up?
It's really cool. I spent so much time focusing on the narrow, like the core pieces, the mechanics, that I don't always get to see the cool demos, so to speak. And obviously Solid's different than React to a certain degree, but to see the potential of where people are taking React, through orchestration, this JSX UI thing sounds really cool, or 3D games, like to actually see that realized, just gives me so many ideas in terms of where these things can go. So I was really excited to kind of hear each speaker kind of talk about their own area, because as I said, sometimes I'm like very much in the core rendering mechanics, so it's really cool.
Yeah, maybe David, do you have some?
Sure. So yeah, when React came out, like it really introduced this idea of everything is a building block, which you could like compose infinitely and connect with so many different things. And now that React's matured, I think we're really seeing these, especially with all the talks that we gave today, where now we're not just limited to frameworks or languages or even rendering libraries like 3JS. Or even like different ways of styling components. So it's just really exciting to see how we're really moving in a way where like we have these libraries that really can connect together, and you don't have to be bought into like a very specific ecosystem. You could really branch out, pick and choose what you want, and create really complex apps with whatever you choose.
Yeah, it's, for me, it feels like we are at the wave of a new wave of innovation. Like I see a lot of things happening again. That, as I mentioned before, I think the way we're going to develop it might be a little different in a couple of years, especially when the technologies get more mature. How about Travis? What did you pick up from the session?
I think just tooling seems to, like, we want tooling to get easier in certain ways, right? And be easy, just like easily express ourselves in making games or managing our state. In my case, like the design element side of things. And so I'm just really excited for that, for more people to enter into this space. I think it's wonderful. Code and design are very powerful. and can take your ideas as far as you want to go. And so it'll be exciting to see more people get into this field if we can lower that barrier to entry.
Yeah, makes sense. And I guess, Paul, what did you pick up?
Yeah, really interesting, these demos. And what I like the most is how out of the box everything seems to be. So what started with a simple idea of reactivity, just, I don't know, this goes beyond of what we have been thinking about it initially. I really liked it.
Yeah, I think it was a great session, and we had cool demonstrations. As I mentioned, it was the first session of React Finland, the opening session, first out of 15. We will see a lot more during the week. So we have architecture session tomorrow, and then from Wednesday to Friday, it's full of content. Since there are no more questions at the chat at YouTube, I think we can wrap up. And thanks for all the speakers and your presentations and demos. And I hope we see someday in Finland when things get better. So thank you. Bye.
Thank you so much.
Thank you.
Thank you.